how Go is going to make it faster and why they've chosen Go in order to port that compiler. And what do you mean by porting? Why it is not a complete rewrite? So that's a very crucial point that everyone is missing and misunderstanding here. If you go here, they have clearly mentioned in the discussion that why port instead of a rewrite. So there is a basic difference, okay, between a porting and rewriting. We'll discuss that as well. Hey everyone, welcome back to the channel. So today I want to share some exciting news from the programming world. So Microsoft is making a big move to port their existing code base, not rewrite but port their existing TypeScript from TypeScript to Go, and they are making a big move to speed the TypeScript up by 10 times faster than existing TypeScript version. Like how are they planning to do that? So what they're planning to do is they're planning to port its compiler using Go programming language. So let's break down what does it mean to our developers. All right. So first thing is, what is TypeScript? I mean, I'll just briefly explain what is TypeScript is. So TypeScript, it is a language developed by Microsoft. So that builds on top of JavaScript by adding some static typing checks, and I mean, which helps catch errors as early as possible, and during compile time only you'll be able to find all the errors, because JavaScript is dynamically typed, but TypeScript makes it statically typed. But the main reason is, as the project grows larger and bigger, right, the compiling process in TypeScript gets little bit slower, and it can consume a lot of memory also. So if I just give you a brief about how the TypeScript compiler works, I won't waste much of your time in explaining all the components in detail, but I'll just give you a brief before we start jumping about how Go is going to make it faster and why they've chosen Go in order to port that compiler. And what do you mean by porting? Why it is not a complete rewrite? So that's a very crucial point that everyone is missing and misunderstanding here. If you go here, they have clearly mentioned in the discussion that why port instead of a rewrite. So there is a basic difference, okay, between a porting and rewriting. We'll discuss that as well. So before that, let's just understand how the TypeScript compiler works actually. So as soon as you write your source code in TypeScript, in current version I'm talking about, so the TypeScript code is finally converted into the JavaScript code. That's the end goal of the entire compiler. So the first step is the source code is converted to tokens by scanning the tokens in your source code. For example, if you have some line called, let's say, let num is equal to number is equal to 10, right? Let number, let's say I write let number is equal to 10. So each individual token, it will be fetched, let num, then colon, then number, then equal to 10. So once the tokens are generated, now the parser tree, the parser that is there, it will parse the tokens, then it will build an abstract syntax tree. You can read about abstract syntax tree in the Google, you'll understand. I'm not going to explain in detail. So basically the AST or the abstract syntax tree is a hierarchical tree structure. All right. Hierarchical tree structure that represents the grammatical structure of the code. The way we have written the syntax and already, it will create an abstract syntax tree for that. Then there is a binder. Now, what the binder does is the binder will traverse the abstract syntax tree that was generated in its previous step, and then gather some information about the variable declaration, their scopes, and all those things. Then it will try to establish a relationship between different parts of the code, such as which variables are declared and where and how they are processed and how they are used. It will try to get the relationship between the variables and the code pieces that's there inside. Then the compiler stage passes to the type checker stage. So type checker check step basically analyzes the abstract syntax tree to ensure that the source code adheres to the TypeScript type rule, right? It is a statically typed language, so it has some rules. So the type checker ensures that it is binding to it is adhering to that rules. All right. It also verifies that the variables, the functions that we have defined right in our code, they are used in consistent with the declared types, then the return types, then the parameter types, everything, which helps the TypeScript compiler to catch errors during build time itself. A simple example will be, let's say you have defined a function which takes one integer as the input, but you are passing a string as the input while calling the function. Then type checker will be able to catch that error and give you the error in the build time only. All right. Then there is the transformation phase. So in this phase, the compiler may transform the abstract syntax tree to optimize the code or prepare it for emission stage. All right. So this can include maybe removing type annotations which are not needed in the final JavaScript code. Right. JavaScript is a dynamically typed language. Then we have the emission stage. So the emitter stage converts the transformed abstract tree into the pure JavaScript code, which will then run on the JavaScript engine or in the JavaScript environment. All right. For example, if I have defined let num, just like I showed you, right? So this will be converted into what? Where let's say num is equal to 10 in plain JavaScript. Finally, this is going to be running in the JavaScript engine, made in your browser or in the Node.js. So that's the difference. So that's a brief about how the entire TypeScript compiler works. And currently it is written in TypeScript only. All right. Now to tackle the issues of slow build time, then heavy memory usage, which current TypeScript version has that issue actually. As the code base grows larger, it will fall into these issues. To tackle these issues of slowness and memory consumption, what Microsoft engineering team has done, they've done a interesting thing. They are coming up with a 10x faster TypeScript. And how they are doing it? They're completely, re-implementing, or I can say not rewrite. I won't again use the term rewriting. It is a porting. I'll explain what do you mean by porting actually. They are porting the entire TypeScript code base compiler into Go. Alright, so Go is known for its efficiency and speed. We all know that. So which makes it a great choice for this task. Again, they evaluated a bunch of programming languages and then finally decided on Go. What were the criteria for deciding for choosing Go? I'll also explain about that. They've mentioned all the reasons here. Before that, let me just go to the article and show you the comparison, like how much performance improvement they've received when they compared the performance between the original code base that was designed and the Go based compiler for various projects. Okay, if you see, these numbers are quite impressive, right? And this is a performance comparison, like how much, I mean, what was the performance of the current version and what was the performance of the version written in Go. That's a brief about this, right? And if you see the numbers, look at the numbers, it's quite impressive. If you, for example, compiling the Visual Studio code base, which has around over 1.5 million lines of code in the VS code base, now just takes 7.5 seconds with the new compiler which is written in Go, compared to the 77.8 seconds which was taking in the old one. Their 1.5 million lines of code took around 77.8 seconds to compile in the current build, while the native one takes only 7.5 seconds, which gives around a 10.4 times of speed improvement. So that's quite pretty much impressive and a very strong reason, and gives a very valid and strong reason to go for a native code base, right? So not only is the new compiler faster, but the new compiler also uses the less memory, which makes our development life easier. But the crux here is it is not released yet. It's still under development. They are going to release it in mostly in TypeScript 7. It doesn't mean that they are going to end the support of existing TypeScript version which is written in JavaScript and TypeScript. They will still continue supporting the existing TypeScript versions till, I think, if you see here, the JS-based code base will continue development into the 6.x series. The TypeScript 6 will introduce some deprecation and breaking changes to align with the upcoming native code bases. So that's their plan. They are going to support both the code bases so that, all the companies, all the projects that are built upon the current TypeScript version, they cannot directly migrate to TypeScript 6 or 7 right upfront overnight. So there will be support for both of them, but gradually they will move to TypeScript 7 as and when they feel that, I mean, the entire TypeScript ecosystem has adapted to the new compiler version. So Microsoft has codenamed this project to something called Project Corsa. Alright, and they're planning to release a preview of the command line type checking compiler by the mid 2025. So what will be the benefits of this then? The benefits of this will be your development experience and development speed will become faster, and the compiling process will also become faster. So porting the compiler into Go, not only speeds up the compiler process, but it also helps in improvement in the project load time, then build time, everything. Now, if you just go to their official documentation of the project repository, so this is the project repository. If you click here, you'll land here. So this is where the current TypeScript version is under development. They mentioned all the things here, like which one is currently under progress, which one is completed, which one is ready. All right, everything is mentioned here. So hopefully we'll be able to have a full-fledged version of this by the end of maybe 2026. What's here? Let's see that. Now comes the main interesting part. Why not Rust or any other programming language? Because everyone is talking just about Rust is better than Go and all of that stuff. But you have to understand why did they do that. For that, if you just go to the discussion section of their TypeScript Go repository and you go to this frequently asked questions section, you will see that the two popular pinned questions are there. Why a port instead of a rewrite? That's the first question. And why Go? If you just open it, why are they doing a port instead of a rewriting? So if you go by the definition, in a rewrite, you start with nothing and implement a new system that tries to solve the same problem as the original one, disregarding the implementation strategies of the original code base. That's about rewriting. You are not bothered about the existing code bases. You are only bothered about the flows and the business logic that you want to extract out of it and rewrite it with the new syntax of a new programming language. But porting, in a port, you take the existing code base and convert it into the new language while trying to keep as much as same code as possible. Same code is in not obviously the syntactically same, but the flow wise, the structure wise, the module wise, it should be similar. Now, if I just give you an example of the porting that they are doing, so this is the existing Go version. Sorry, yeah, this is the existing Go version of a particular module inside the TypeScript compiler code, and this is the existing TS version. So this is the Go version. This is the TypeScript version of the source code, compiler source code. Now, if you see, it doesn't have much of a difference because Go is almost structurally similar to TypeScript. So they have opted for Go. This makes their first criteria because porting to a given code base and porting to a particular language is much easier than rewriting everything, because rewriting takes whole lot of time than porting. And if you see structurally, they are almost similar. And if someone is acquainted with TypeScript already, they won't take much time to go through the Go code and implement things in Go. And also Rust or any other programming language, especially the argument that is going on around the Rust, it takes a lot of time to learn. It has a steeper learning curve than Go. So that's the first thing. Porting is faster to execute, but requires the new language to be at least somewhat architecturally compatible with the original language. This is what I was talking about. And porting also tends to bring over any existing bugs and quirks to the original code base. But if they had done rewriting might introduce a new bugs, new issues in the code, and a lot of projects and ecosystem out there is already dependent on the TypeScript ecosystem. They are in the TypeScript ecosystem. So if a simple bug that is released, right, a simple old bug is released into the production, then it will break a lot of projects throughout the world, right? And it can disrupt a lot of businesses. So you can just go through this entire explanation that they've given, like why they're porting instead of rewriting. That's the first explanation. Why porting instead of rewriting? The next question is why Go? So if you just go here, you will find a lot of interesting things here. Okay, all right. Language choice is always the hot topic. It's worth explaining a few of them. This is the first point that I are giving. By far the most important aspect is that its structural alignment with JavaScript. Alright, so Go's structural similarities to JavaScript, which I showed you right here. So it makes more intuitive for developers in transforming the existing JavaScript code or TypeScript code to Go code. That's the first point. And the second thing is concurrency and scalability. So Go has a built-in support for multi-threading and concurrency and routines, right? Go routines, which can support the multi-threading capability of the compiler to handle concurrent tasks efficiently. All right, and which can lead to improved ability and performance definitely. And next thing is about the memory management and compatibility. So, and this is a very much important point. We also have use a large amount of graph process like abstraction, text tree, and all those things that I explained. Specifically traversing the trees in both upward and downward works involving polymorphic nodes. Go does an excellent job of making this ergonomic, especially in the context of needing to resemble the JavaScript version of the code. So this is one more justification. It makes them Go is quite structurally similar and does a very good job while traversing through the abstract syntax tree up and down, upwards and downwards, and parsing the code. All right. So you can just go through the entire explanation that I've given, like why they have opted for Go and not any other language. So it will give you a very good idea about it. All right. So I'll put the link of all the articles in the description. You can just go ahead and check it out. So that's all for today. So if you found this information helpful, don't forget to like and subscribe to my channel. Let's target for 50 likes to this video, and hit the notification bell for more such updated tech videos like this. So until next time, happy coding, and I'll see you in the next one. Thank you for watching this video. And if you have any questions, let's have a healthy discussion in our comment section. So thanks for watching this video, and I'll see you in the next one.